Welcome to another exciting educational video brought to you by Upvision Concepts Academy. So today we'll be looking at JAMB style questions on logarithm, surds, sets, and Venn diagram. We'll be looking at all the questions that have come out in JAMB or JAMB style questions in these topics. So sit tight. If you're to subscribe to our channel, kindly subscribe to Upvision Concepts Academy for more exciting videos in the STEMs. So we dive in. So we have this question on the board. It says if log 1000 is equals to x, then s is what? And we have options here. A is 1, B is 2, C is 3, and D is 4. This is a typical JAMB question. So the first thing you do, take a deep breath. You just write log 1000 to base 10. We know that x is to base 10 already. Okay, so this 1000 expresses in form of indices. So again, log to base 10, 1000 is expressed as 10 raised to the power 3 is equals to x. Now you know, as a rule of logarithm, if you have a number raised to an exponent and they are all in the base, the exponent will come and be the coefficient of this expression here. So 3 will come and multiply log 10 to base 10. So this one will come down to this side, and you have it as 3 log 10 to base 10 is equals to x. Again, another law says that log to the same base is equals to 1. That is log a to base a is equals to 1. Log b to base b is equals to 1. And log 10 to base 10 is equals to 1. So this now becomes 1. So it's 3 times the whole of this is now 1 is equals to x. Therefore, x is equals to 3. So if x is equals to 3, the option is option C. So again, number 2, we have log 8 to base 2. What is it? Log 8 to base 2, what is it? So I'm giving the same option again. Now, we'll have to express this 8, the power of its index, so of its factors. So log 8 now becomes 2 to the power 3 to base 2. Why? Because 2 times 2 times 2 will give us 8. We just expressed 8 in its factors, the stand power of its factors. So again, we have that if you have an exponent here, this exponent can come to be multiplicand of this expression and leaving this position. That's one of the laws of logarithm. So 3 will now come before log 2 to base 2. So 3 just left here to this side, and what I have is 2 to base 2. Again, we know that log of any number to base the number is 1. So log of 2 to base 2 is 1. So 3 times the whole of this expression becomes 1. Understand? 3 times 1 is 3. So this log 8 to base 2, the answer is 3. That's option C. Again, we have number 3 on the board. It says log 2 plus log 5. What is it? These are the available options for this question. And this is just to test us on the product rule for logarithm. We know that log 2 plus log 5 is the same thing as expression is the product of the two in the same base. If you have a positive, a plus sign, plus operator in between two terms, you just change it to multiplication, maintaining the same base. So it's same thing as saying log in the same base is equals to 2 times 5. So log in the same base is equals to 10. And therefore, log 10 is the answer for this expression. B is the option to match what we are doing here. Okay, see another possible JAMB question for JAMB exams. You see log 50 minus log 2, what is it? And you have options to pick from. That is if any of them is correct. So we'll identify that the operation here is minus, and they're going to testing us in the use of quotient rule, which says that if you have log minus another log, then you take, and they are of the same base, you take the quotient, that is division of the two to the same base. So we go. So log 50 minus log 2 translates to log in the same base of 50 divided by 2, because you're having minus here. Okay, so we'll go ahead and divide 50 by 2. The product is, the division is 25. So the answer is log 25. In simple form, A is the correct option. Okay, so we're moving up. Log 0.001 to base 10. What is it? Look at the options here. So we'll quickly inspect this. Now, this is in decimal form, and if you express this in fraction form, you have it as log 1 over 1000 to base 10. Now, I'll just do a side note here. 0.001 is the same thing as 1 over 1000. How? Because by the time I start moving this decimal point to the right, I have 1, 2, 3. That determines the number of zeros I'll be having all over. That number of zeros I'll be having behind the ones. You understand? So this is how I converted 0.001 to a fraction. Now, this is the same thing as saying in index form, 1000 minus 1. So it is log 1000 minus 1 to base 10. Already, I can also express this 1000 as powers. So log, this 1000 is 10 to the power 3 dot minus 1. This dot is multiplication, right? So to base 10. So what I'm having here is, I've expressed this 1000 here as a power of tens, factors of tens. That is 10 to the power 3 will give me 1000, but there's a minus 1 here. So all of this will become log 10 to the power minus 3 to base 10. So this one is now this. So at this point, I will take the minus 3 here, this power, this exponent, minus 3 here, to multiply the coefficient, that is 1. It will come to this position, and I have it as minus 3 log 10 to base 10. Recall, anything to base the number, the same number, is 1. So this is now minus 3 into 1. And finally, minus 3 is the answer. So minus 3 is the answer. The option here is B. Stepping up again, here I have this in equation form. This is 5 raised to the power of x plus 1 is equals to 125. Find x. So what we will do is that we will look at the left-hand side of the equation and right side of the equation and see how we can express both of them in the same base. This is 5 raised to the power x plus 1, and this is 125. 125, how can we express 125 as an index of 5? So 125 is the same thing as 5 times 5 times 5, right? So I have 5 x to the power x plus 1, which is this, is equals to 125 now be expressed as 5 to the power 3. So note that we have expressed both sides of the equation in terms of 5. In terms of 5. So if the bases are the same, we equate the powers. So let's go. X plus 1 is equals to 3. That is equating the powers. So when I've done that, x is equals to 3, then minus 1, and x is equals to 2. So x is 2 in this expression. Answer is B. So another possible JAMB question this year on logarithm is log 32 to base 2. What is it? Okay, again, you just express this as a power of a lower number. So 32 is the same thing as 3 to the power 5. Okay, So I'll say 2 raised to the power 5 to base 2. How do I know that 2 raised to the power 5? I break 32 down, for instance. I have 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, times 2 again, which is 32. So this is the factorial, not factorial, the factors of 32. That is 2 times 2 times 2 times 2 in 5 places. That's why I replace this, all the whole of this, that is this, with 32. Sorry, I replace 32 with the middle of this. So that's why I'm having 2 to the power 5. Again, I can now take the exponent here and multiply by the coefficient. So I have 5 times log 2 to base 2. So anything to base the same number is 1. So 5 times 1 is equals to 5. So log 32 to base 2 is 5. That is B. So another JAMB question, possible question for this year is simplify log 10 plus log 0.1. So, and these are the options that we are looking at. So they are all in base 10. They're all in base 10. We are assuming base 10. If we are not giving any specification, we are assuming base 10. Okay, so I can simplify this, individually. I would say log 10 to base 10 is actually 1 already. But for this one, log 0.1 to base 10 is the same thing as saying log 1 over 10 to base 10. Same thing as saying log 10 minus 1 to base 10. And same thing as saying this minus 1 comes down. It now becomes minus 1 times log 10 to base 10. And log 10 to base 10 is already 1. So this times 1 is equal to minus 1. So I have this first term, log 10 plus log 0.1. I have log 10 already, that's to base 10 as 1, and log 0.1 to base 10 as minus 1. So 1 plus minus 1 is the same thing as 1 minus 1, which is a 0. So 0 is the answer to this particular question. Okay, so number 9 here says simplify root 98. This question in the JAMB syllabus is under Surds. So this is a Surd, simplify. So we can start by breaking this into its components. You know that 98 can be written as 49 times 2. This and this are the same thing. Why? Because 49 times 2 is 98. So I will rewrite the question again and say what they are asking me to do is to simplify this. 49 times 2. Okay? Don't rush to go and choose this number, this option. It's not that one. So it is the same thing as saying root 49 times root 2. Root 49 itself is 7, and root 2 is irrational and cannot be simplified further. So a final answer is 7 root 2. Notice how you have computation of 7 root 7, 49 times 7, all roots. Understand? You are seeing numbers similar here. Don't rush to pick any of them. Just simply be patient, check the answer very well, check the options very well, and pick your correct option A. Most times, mistake comes because you do not look at what you have calculated carefully to match with what you have as the options. Okay, now for number 10, it said rationalize denominator. That's this one. This is a Surd in fractional form. This is denominator of it, and this is the numerator of it. So we have to rationalize it. So what we do as to rationalize is to inspect. Okay, I'll write out the question again. 5 over root 3. So this here is known as the numerator, the number on top of this divisor, and this is the denominator. Now, to rationalize, inspect the denominator. Whatever you have as denominator that is in Surd form, multiply it by that value, numerator and denominator. So you will say, you will just write times root 3 and divided by root 3. So what I've done is to use this number here to multiply both numerator and denominator. Whatever you have here, you understand? This is for this case. There are some cases where you have used conjugates. We'll talk about that in the next video. We have to use conjugates. So, but this is just a single fraction. So 5 times root 3 is 5 root 3, and root 3 times root 3 is 3. You see, any surd multiplying itself is the number without the surd. So you have root a times root a will give us a, root b times root b will give us b. This can be easily proven. It's easily proven. Let me prove for this why this and this gave me this. If I have root 3 times root 3, 3 times 3 is 9, so it's root 9. But root 9 itself is 3, right? So I don't have to go through this process to get 3. Once I see root 4 times root 4, for instance, I say the answer is 4. I don't have to say 4 times 4 is 16. Then root 16. Root 16 is 4. Okay, so this is the final answer, and my option is option A. So for this video, we'll stop here. I hope it has been informative for you. I'll see you in the next video where I will deal with the part 2 that will conclude the surds and sets.